here is an example from joint distributions, meaning we have two variables. We want to look at the probability that x equals x and that y equals y. So here we have an example where an employee works x hours per week at an hourly wage rate of y. So we have both a random variable of the number of hours worked and the hourly wage given they work that many hours. So we can write that out in this type of format here, where we have the probability that x is equal to x and y is equal to y will be based off of the different values of both x and y. So we can rewrite this distribution in the following way. I can identify here when y is equal to 10 and y is equal to 15. These are the two potential outcomes for y. And I can identify when x is 20, x is 30, and x is 40, the number of hours of work. Now, based on these, the matrix, sometimes this is helpful to see. I can then look at the table, and when x is 20 and y is 10, that's this first observation there, then the probability is 0.2. When x is 20 and y is 15, the probability is 0.1. And I can keep working through this table accordingly to have that match what we have. And so what this is saying, this right here is saying, what is the probability that x equals 20 and y equals 10? So that's what that exact cell is telling us. That is what we call our joint distribution or a joint probability. Now from this, we can then calculate, well, what if we want to come up with a marginal distribution? What if we want to look at the probability of x happening? Well, if that's the case, then one thing we can look at is we can look across here to see what we're going to call the probability that x equals x. And this is going to be our marginal distribution. So we'll call this the marginal. And all we have to do is just add the probabilities across both potential outcomes of y. And so here is where we have our marginal distribution. Let's see if we can make that line just a little straighter, of x. So that's one way to write it within this table. The other way we can write it is based off this table. And again, with this marginal, we'll put a little sub x there, is the probability that x equals, and this little x here just lets us know this is coming from a joint distribution, would be 0.3 if x equals 20, 0.3 if x equals 30, and 0.4 if x equals 40. And if we were to add up a marginal distribution, they should add up to 1. We can do the same thing for y. Let's move this down just a little. Is we can find the marginal distribution of y and just add up the columns now. So this is 0.4 and this is 0.6. Sorry, add up the rows. So this would be the marginal distribution of y. We could also rewrite this as the probability sub y, that y is equal to y, is 0.4 if y equals 10, and 0.6 if y equals 15. And so now we have, from our overall joint distribution, we've been able to calculate the marginal distributions. Well, now if we have a marginal distribution, we can then turn to Bayes' law, which says, so here is Bayes' law, that the probability of A condition on B is equal to the probability of A and B over the probability of B. So given that I have a joint distribution up top and a marginal distribution on bottom, I can calculate the conditional distribution. So if I wanted to look at the conditional distribution, I could look at what is the probability of y equals y, condition that x is equal to 20? Well, if this is the case, this will equal the probability that y equals y and, oops, let's make that a little y, and x equals 20 divided by the probability that x equals 20. So if I look over here, what's the probability that x equals 20? That comes from our marginal distribution. So that is 0.3. And the probability that y equals y, given that x is 20, is we're going to be looking here, and it's going to take on one of these two values. So if I then look at, change this, what's the probability that y equals, not y, but let's call it 10, then this would be 0.2 divided by 0.3. And so this would be a probability of 2/3. And we should also then make note that we should change, change this value to also be 10. And so we could then find the next one, probability that y is equal to 15, given that x is equal to 20, equals the probability that y is equal to 15 and x is equal to 20 over the probability that x is 20 is now going to be, the denominator stays the same, and I look over here and now it's 0.1. When x is 20 and y is 15, we'll get 0.1. And so now we have the conditional distribution of y when conditioned on x is 20. So I could rewrite this, the probability that y is equal to y, given that x is equal to 20, is equal to 1/3 if y is equal to 10, and 2/3 if y is equal to 15. So I can write out those distributions that way, both a joint distribution and a marginal distribution and a conditional distribution. Now let's look at one last thing we can do with this, is from these we can calculate our summary statistics, which is typically the expected value of x and the variance of x, and also the standard deviation. Well, let's suppose we're going to look at the variance of the expected value of x. Well, if I want to look at the expected value of x, this is going to equal, we take the summation over the values of x times the probability that x is equal to x. In this case, we're going to look at the marginal distribution. So in this case, we can look at the marginal distribution, which is going to be here or here. Both of those are the marginal. And so we can then write this as equal to 20 times the probability 20 happens, which is 0.30, plus 30 times the probability that happens, which is 0.30, plus 40 times the probability that happens, which is 0.40. And if we do that, we get the expected value is equal to 31. So if we ask, based off of this distribution, how many hours do we expect the person to work? The answer would be 31. We can also find the variance of x, which is expected value of y of x squared minus the expected value quantity squared. So expected value of x squared is 20 squared times 0.3 plus 30 squared times 0.3 plus 40 squared times 0.4. And that's the expected value of y squared, of x squared, sorry. So the variance of x is that number. We'll just call this theta. Actually, we'll calculate it out for you. Let's break out my calculator. So we get 20 squared times 0.3 plus 30 squared times 0.3 plus 40 squared times 0.4. That is equal to 1,030. So the variance of x is 1030 minus 31 squared. And that number is equal to 69. So there we can calculate the expected value using our marginal distributions. Furthermore, and we won't show it here, we can also use our conditional distributions right here to calculate the expected value of x, the expected value of y given that x is equal to 20. And this will be simply the summation over the y times the probability of y given that x is equal to 20, which is what we saw right here. And we'd use this distribution to find the expected value of y. So real quick, let's just plug that. Let's do a quick example here. So when y is 10, that happens 1/3 of the time, plus when y is 15, that happens 2/3 of the time. And so this would equal 10 divided by 3 plus 30 divided by 3 is about 13.33. So that is the expected value of y given that x is equal to 20. And we can do a similar thing for the variance. So there's where we can look at a joint distribution to calculate our marginal distributions, to calculate our conditional distributions, and to estimate summary statistics both of the marginal distribution and of the conditional distribution.